Hey guys, this is Bill. Welcome to my channel. Today I'm gonna demonstrate how the test statistics for an unpaired two-group comparison is derived. First, let's list out the assumptions that we make for unpaired two-group comparison. So, let's assume that there are two populations that are independently distributed, and let's call them x1 and x2, alright? So x1 follow a normal distribution with the mean being mu1 and the population variance sigma square. Alright? So x2 follow a normal distribution with the mean being mu2 and a population variance sigma square. So here you should realize that we assume that these two populations have their own means being mu1 and mu2. However, they share the same variance sigma square, alright? When we have two samples from these two populations, x1 and x2, we can obtain the distribution of the mean of the two samples. So x1 bar should follow a normal distribution with the mean mu1 and the variance being sigma square divided by n1. And similarly, x2 bar follow a normal distribution with mean being mu2 and this variance being sigma square divided by n2. So x1 bar minus x2 bar should follow a normal distribution still, with the mean being mu1 minus mu2 and the variance being sigma square divided by n1 plus sigma square divided by n2. Alright. So your x1 bar minus x2 bar minus bracket mu1 minus mu2 divided by the square root of sigma divided by n1 plus a sigma square divided by n2 should follow a normal distribution, which is the standard normal, alright? So now let's recall that your t-distribution is basically a standard normal divided by the square root of a chi-square distribution divided by its own degree of freedom, alright? So now that we have already found out what follow a standard normal, we should find another expression that follow a chi-square distribution, alright? So I'm gonna give you the expression straight away, but if you want to know how to derive such an expression, you can watch my previous video on hypothesis testing. So here, I'm gonna tell you that n1 minus 1 multiply s1 square, which is the sample variance of the sample from population x1, alright, divided by sigma square, which is the population variance of x1. This expression follow a chi-square distribution with a degree of freedom n1 minus 1, and similarly n2 minus 1 multiply s2 square, which is the sample variance of the sample from population x2, divided by sigma square, follow a chi-square distribution with a degree of freedom n2 minus 1. So recall that your x1 and x2 are actually two independent populations. So you can add up these two expressions because the two of them are actually independently distributed. If you add them up, this expression follow a chi-square distribution with a degree of freedom n1 plus n2 minus 2. Alright. Next thing that we should do, naturally, we should divide this expression by its own degree of freedom, alright? Because this is what we are supposed to do in a t-distribution. Let's divide it by its own degree of freedom, which is n1 plus n2 minus 2, alright? So on the right hand side, we also divide it by its own degree of freedom, alright? And you should realize that this part of the expression is exactly the population variance, the pooled population variance. So we should call it S pool square. Alright? So now you realize that S pool square divided by the population variance is exactly what we want in the denominator. Alright? So later on, I'm just gonna refer S pool square as s squared, alright? Because it's simpler that way. Okay, so we found a statistic that follow a chi-square distribution, which is here, and we also divide it by its own degree of freedom, alright? And we have also found another expression that follow a standard normal. Now we just need to plug in these two expressions into the T-distribution statistic. After plug them in, you realize that we can cancel out the sigma square term, alright? What you should have is x1 bar minus x2 bar minus mu1 minus mu2 bracket back divided by square root of s squared multiply 1 over n1 plus 1 over n2. So this expression is the test statistic for a two-group comparison, and it follows a T-distribution with a degree of freedom n1 plus n2 minus 2.